Well, hi everybody. Today we are going to look at inverse function. This subtopic can be somehow quite confusing to students as they cannot really distinguish or make any difference about inverse function and also the usual function. I believe that in order to well learn this inverse function, we need to deep through about what is function actually. And in the previous class I already explained about that, and I'm using the analogy of the vending machine in the last class. Okay, so function is basically a relation that satisfies either one-to-one or many-to-one relation. So in short, function must have only one output. It cannot have more than one output like that. Okay, and for the vending machine analogy, so just think of like when we purchase a item in the vending machine, so we need to have money. For example, I fed in money RM5 ringgit into the vending machine, and in return I will get the item, for example about Coca-Cola or whatever snacks that you prefer. So the money here is like an input, and then in return we will get the output. So what is the relation? The relation is as long as you get, or as long as you have the money to feed in or to insert into the vending machine, you will get the item, right? So that's the relation, and then the relation is one-to-one. You have one money to be inserted and you will get one item. Okay, goes out like that. So this is the very short or brief analogy about that, right? And what about inverse function? How can we abstract the inverse function, or how can we think of inverse function? Okay, let me draw an arrow diagram here. So usually we have an x as the input. So this is the standard in any textbook in the world that you can see. So this is our input. X will serve as our input, and we have y, or usually we write y as f of x in this subtopic. Okay, so y will serve as our output. So what is the relation, or how can I go from x, or from the input to the output? So I need to have a relation one-to-one or many-to-one. So the relation must be f of x. It can be any expression, for example 2x plus 1, x over 2 plus 1, and so on and so forth. So I just put in general it's f of x, or f. You can put it like that. Okay, and then this is usual function. I call it usual function. Okay, and what is inverse function actually? Back to the question. Inverse function is basically you reverse the direction of the arrow, right? You reverse the direction of the arrow. Instead of from x to y, now we have y to x, right? Y to x, which means we have y to be our input now, because we starts off from y. Okay, so now our input is y already. Okay, so we just flip the input to be y, and then our output to be x already. This is our output. Then this direction, I call this direction as inverse direction. Let me write this to be inverse. I will write it as inverse direction. So how we can represent in mathematical notation? Well, I believe you know the answer. So it will be f of y. Okay, f of y. Because here you have f of x when you start from x, and then this one you have f of y now. But usually in mathematics, in this chapter particularly, we need to represent our expression, our function, in terms of x. So what we do is basically we write like this, f. Okay, it's like this is not power -1. This means inverse of x. F inverse of x, like that. Okay, so that's not the power -1 we put there. Okay, that's how we represent inverse function. Okay, so we have two ways to represent, either fy or f inverse x. So this is similar. Alright, so let me give an example. For example, if I have f of x equals to 1 minus 2x, okay, how can we calculate for the inverse? So this is the inverse. First of all, as you can see here, okay, we can represent our function as y, right? So we can represent it as y equals to 1 minus 2x. This is the first step. The second step is basically you make x as our subject of formula. So maybe I can try to let me eliminate negative 2x on the right hand side, so plus 2x, or you can say you shift negative 2x to the left hand side, so it doesn't matter. So I have 2x equals 2, and y I just move to the right hand side, so I get 1 minus y, like that, right? And then I make x as a subject, so I divide both sides by 2. This one cancels, and then I get x equals to 1 minus y. Okay, remember, if we can make analogy over here, if just now I say that fx is basically our y, because fx is basically the output itself, the output for the usual function, output for usual function. Now we have fy, fy is corresponds to inverse function, and the output for fy is basically x itself, right? The output for the inverse is basically x, and x is basically, we can represent x as fy. So can you think this as like, so you can think it, so it's similar. When you have f of x here for the usual function, we can represent it by y, because y is the output. Same goes like when we have f of y, you can represent it by x, because x is the output for the inverse function. So x is basically fy. X is fy. So what is x? X is fy. So we get our answer 1 minus y. But usually we represent everything in terms of x. So because fy is basically another way of saying f inverse of x, right? F inverse of x. But I cannot write 1 minus y as the answer, as the final answer, because we have the argument. This is the argument. We call this as argument. The argument is in terms of x, which means the expression here must be in terms of x as the variable. We have y here, so it is not compatible. So we need to change the variable, so it becomes 1 minus x. Okay, we need to change the variable to make it compatible. So our final answer is basically the inverse of f is basically 1 minus x. Done. Sorry, 1 minus x over 2. So I forgot to divide it by 2. Over 2, over 2, over 2, over 2. Okay, sorry for that. Okay, we have 1 minus x over 2. So that's the concept about the inverse function. I think that's all for now. Thank you very much and see ya.